would be some practical considerations to think about in terms of the best way to set up mining operations on Mercury. But these are questions we're already putting our minds to. Anyway, scientists are currently working out how to set up bases on the Moon, with similar intentions. We're not far away from doing the same on other planets, once we have the techniques down. In other words, there really aren't very many barriers left towards attaining the immense energy of the Sun. A Dyson sphere might well be another example of something that sounded like science fiction to us, but will turn out to be something our children or grandchildren will one day come to take for granted. In the middle of the day, the sky starts to darken. It's as if dusk has fallen early. People look and notice something is happening to the Sun. A dark shadow moves before it, gradually devouring every last trace of brightness, until our familiar light-bringer is only a shimmering ghostly ring around a pitch-black orb. A total eclipse is occurring. This will soon be a reality. One is coming to the continent of North America in April 2024, but if, like me, you are one of the many billions of people who won't get a chance to see that particular solar eclipse. This April, you might be glad to know that America is not the only place they happen, and neither is Earth. Have you ever wondered what a solar eclipse looks like on another planet? Wonder no more. I'm Alex Milan, and you're watching Astram. And today, we're exploring solar eclipses. But not just the ones that happen here on this planet. Allow yourself today to feast your eyes on the actual images and even videos NASA has taken of spectacular eclipses from various places around the solar system. Firstly, I'll quickly explain some of the terminology to do with eclipses. A total solar eclipse is when an object moves in front of the Sun, completely obscuring it. Also known as an occultation of an object. This is the typical kind of eclipse we see on Earth, when at certain points in Earth's orbit, the orbit of the Moon aligns with the Sun. There is something special about an eclipse here on Earth, and I'm not just saying that out of some Earth-focused pride. By a bizarre but highly fortunate cosmic coincidence, the Moon is the right size and distance from us that his angular diameter is almost identical in size and shape to the angular diameter of the Sun in our sky. This leaves for an impressive spectacle where the corona of the Sun, or in other words, the Sun upper atmosphere, creates a ghostly aura around the Moon. This corona, normally too dim to see, extends for hundreds of thousands of kilometers into space, looking closely around the edge of a total solar eclipse, and you will also see the silhouette of the Moon's craters along the outside, plus these reddish wisps coming off from the Sun. These are prominences millions of times of charged particles suspended in the Sun's atmosphere by powerful magnetic fields. During an eclipse here on Earth, the Moon casts a shadow about 250 kilometers in diameter, which moves across the Earth as the Moon orbits in the case of the eclipse, happening this April. This shadow will arrive at the Mexican west coastline, then will make its way up through the United States until it passes into parts of Canada, before moving over the ocean. Once more, you can see on this map the path the shadow will take, if any of you happen to live in its pathway, or are close enough to make the drive. You may want to try and see this eclipse for yourself. The Sun will only be totally obscured within the diameter of the shadow. Outside of that, the Sun is only partially obscured from the viewer's perspective. This viewer is witnessing an annular or partial eclipse, also known as a transit. The shadow moves across the Earth extremely fast, at roughly 1 km a second, witnessed from a high altitude. It is a majestic sight as the shadow shifts across the landscape. Satellites have also witnessed the movement of this shadow. The shadow isn't as sharp as you might expect, and this is due to the angular diameter of the Sun and the Moon, and their distance apart. The Sun itself is huge. A whopping 1.4 million kilometers across the Moon is much smaller at only 3,400 kilometers across. Now, This image isn't to scale, but it shows visually why the shadow isn't sharp. The umbra is the shadow where the sun is completely obscured, and the pen. Umbra is the shadow where the moon only partially obscures it. This part of the shadow is much wider than the 250-kilometer wide umbra shadow. So why doesn't the moon create eclipses every month when it orbits in front of the sun? Sun? Well, this is because the moon's orbit is not in line with the Earth's orbit around the sun. This means there are only a couple of times per year when the alignment is right. This alignment of three celestial objects is known as a psi. A very cool word, but not something you'll need to remember for this video. I just thought you would find that interesting if you live in the UK like me. Sadly, you won't get to see much of the eclipse this April, unless you live at this west parts of the country, as the sun will be dipping below the horizon just as it begins. Maybe we will get to see some devil's horns, though, still a spectacular sight indeed. But the Earth is not the only place to experience solar eclipses. And we have the images and videos to prove it. Let's explore eclipses of our closest celestial neighbor, the moon, because it would make sense that if the moon can occult the Earth, then surely the Earth can occult the moon.